Hey guys, I have a very interesting light bulb here. Looks kind of like one of those projector bulbs, but it's not really what it is. Let's power it up and see what happens. Okay, have it hooked up to the power supply. I'll just bring the voltage up and we'll see what happens. Nothing yet. Oh, the filament is starting to glow. Getting brighter. Brighter. Ooh. Very interesting. It's not an incandescent lamp at all. So what we have here is a low pressure mercury bulb. It has a quartz envelope to allow the UV to escape, and it's used to kill bacteria, antimicrobial, or even produce ozone. And I'm not sure, but they may even use it to cure certain types of adhesives or paint. But it looks like an incandescent bulb. It has a filament on supports. But if you look carefully, you can see the ends of the filament has a lighter shade to it. That's an emissive coating that allows electrons to be emitted from the ends of the filament easier. And as the filament heats up and voltage increases, eventually it'll start a discharge across the ends of the filament there. And that's what we saw with the bluish light. Of course, when you're using these things, you want to protect your eyes because of the energetic UV is quite damaging to your mucous membranes and in your eyes. It could cause a kind of a filling of sand in your eyes. After a while, you may not notice it right away, so you have to be very careful. Okay, hook up the meters here. I'm going to measure the voltage across and current through the bulb. Now, there is a ballast resistor because the nature of electrical discharge lamps, you have to ballast them, or if I just cranked up the voltage and it came on, it would blow out as too much current would go through the ends of the filament and melt it, and it wouldn't work anymore. So I'm going to bring up the voltage here. We're at 13 volts, and you can see there it's starting to get brighter. We're at 184 milliamps. $18 volts. Okay, I maxed out my supply. Why isn't it starting? Oh, there it went. This is a little bit slow. And whew, thing puts off ozone like crazy. I gotta protect my eyes. Kind of acts as a voltage regulator. As I adjust it, it jumps up, but it flattens back out around 12 point something volts. As I increase the voltage, it does drop a little bit due to the inverse relationship. I gotta turn that thing off. There's crazy amounts of ozone. Yeah, the inverse relationship, as you put more current through the electrical discharge, the voltage across it will drop somewhat. That's why you have to ballast it or it'll burn out. Okay, I'm going to hook it up to a voltage regulator set up in current mode. I have the LM317 set up in constant current mode. Well, this bulb is 12 volts, and they say to limit current to around 300 milliamps. So how do you set up an LM317 in constant current mode? Well, you can refer to the data sheet, but I'll just explain it here. Well, you take the input, and that's just a decoupling capacitor, supply decoupling. You take the output pin and connect a resistor between it and the adjust pin. And your output now comes off the adjust pin, just like this. And to calculate, you take the regulator's internal reference voltage, and if you're trying to find the resistance, just divide by the current. And if you're trying to find the current and you have the resistance, just flip-flop the current and resistance here. Well, we want 300 milliamps, so we put in 1.25, divide that by 0.3, which is 300 milliamps. And I need a 4.1666 resistor, ohm resistor. I don't have that. I know I have a 3.9, and we'll go ahead and use that. So I'll just use this bottom equation here. 1.25 divided by 3.9 ohms. About 320 milliamps. And I already put that in there. Let's see if the current is correct. Okay, what I'm doing is shorting from ground to the adjust pin and being in constant current mode. Look at that, 0.319, 0.320. I'd say that's pretty close. And as I adjust the meter, not the meter, but the voltage up and down, it doesn't matter, it stays the same. One thing I should mention though, when you do design this type of circuit, is you must allow for headroom, voltage supply headroom, because there is going to be some voltage drop across your resistor here, and there's going to be some drop out across the regulator down to 2 volts or 2.5 volts, whatever the dropout voltage is minimally. Essentially what happens here is, with the resistor connected in this fashion from output to adjust, it's sensing the voltage drop across this resistor. And to keep a constant current through a resistor, you have to keep the voltage drop across that resistor constant. So what happens is the voltage regulator is adjusting its voltage up and down to keep that voltage across this resistor the same at all times. And like I said, if the voltage drop is the same across the resistor, the current through the resistor is going to be the same, and you'll have that fixed current output. Alright, I have the bulb hooked up to the constant current source, constant current regulator, and we'll fire this thing up and see what happens. Pretty much fires right up, and as I adjust the voltage up and down, the arc does not change. Of course, if we go too low, we fall out of regulation because of that, we're too low for the regulating effect to occur, so it drops out. But it really improves the starting performance of the bulb. fires right up. Whew. Lots of ozone. Can't keep running that thing. Pretty interesting. Not very hot, not dissipating a lot of power. An electrical discharge through a gas is really not a simple process. A lot of things are going on, and it has fascinated physicists for many years. And I think it's pretty interesting. This is a it's not a fluorescent tube because nothing's fluorescing, but it's just a clear tube in one of these battery operated lights. It's a germicidal lamp, a G4T. And you can see what's going on there. That's called the positive column. Anode glow down there at the tips of the anode. Faraday dark space. Cathode glow and other processes you really don't see. Well, sorry about that. My battery gave up the ghost here, so I popped it in for a couple minutes. Hopefully I can finish my video. But yeah, it's a very interesting process, and I'm not going to even pretend that I understand everything going on there, but you can certainly look at it, research it yourself, and learn more about it. But I think it's pretty interesting. Yeah, I give up. My battery quit again. 9 p.m. Saturday night. Me and the kitty have Star Trek to watch. Catch you later.
Put it on audio.
Please hurry. Help us. I don't have much time. They'll know. Please, please.
Areelan,
help us.
this is Jim on the Enterprise.